Okay, so as I told you, so we'll be talking on no code ML tools. So when you say no code, it's so obvious that we aren't going to use a single line of code to do a project, and that too in machine learning. So like all these sessions, so we've been talking about so many different languages and different projects, and everything had required some kind of coding. But this time we'll see something for which we don't need a single line of code, which means any non-technical person who do not have any knowledge in anything, be it Python or even the machine learning techniques, algorithms, anything it could be. So you don't need any technical knowledge to understand this. However, this session may not be appropriate for many professors over here because I know we've been boasting about all the algorithms here, but still, let us also know the other side of the world, like where the entire world is running towards the different programming languages like Python, R, and lot more. Let's also understand that it is not mandatory to actually know all these languages to be a super duper scientist, data scientist. Okay, so that's the ultimate objective of this session. In fact, like I read it in a recent article that um, no code is the future of data science because as you know that uh, we are never short of like IT resources, and we are never short of a shortage of any IT people. Like we have abundant people, and every year the number of college outgoers are like so huge, but still we are in shortage of the talent. Okay, like it's not that every student who passes out even from reputed university or anything is like highly technical enough to go and jump directly into a data science project and work on. So that's the actual problem. So what Granters told is like data science will be the future, definitely. And no code data science is going to be the future because we cannot rely on a computer science engineer to do like all that works. Okay, like when you give the power to a layman, you see that they could do even better things. Okay, so it's all about like you just need the mindset to explore things. Okay, like assume that we got a new phone. The first thing everyone would be interested is to just explore the various options we have. Like we'll just click on each and every options, and then we'll see that we get to know the entire mobile. Okay, we just want to learn as much as we want. We want to explore that. Okay, the same way, if it is going to be that tool, no code data science tools that I told, it's pretty much the same thing. So if you are a technical person, you would keenly go and observe what is the algorithm, what is the coding behind each and every option right there. But if it is a non-technical person, he wouldn't bother about anything. All that he bothers is he want to just explore the different options right there. Okay, so this is the main ideology behind that. And I'll be discussing few tools today, and nothing requires any knowledge about the algorithms or the codings and all. So please excuse me, I'll be not talking anything on the coding or the algorithms behind the thing. I'll be showing you as how to start with those tools. And many professors might already be knowing this, but bear with me because this session has to happen. Okay, let me share my screen and I'll tell you the list of tools that's already available for no-code data science. Okay, so we'll start with a very simple and a very interesting code, which is called as thinkable machines. Thinkable machines. Sorry, teachable machine. Okay, you could see the first link, right? There's something called as teachable machine. This is a very simple tool that even a 5-year-old baby can play around with. It's such a simple tool. So to start with, we'll see this tool first of all. Okay, so this one, it's like more of like drag and drop options only. So simple. Right now, this teachable machine gives you 3 different types of projects actually. So they are keeping on increasing the number of projects. As you could see, the first project is anything related to images. Like it could be anything, right? From cat versus dog classification to much more. You could think of any high-end projects that could use images. Even hyperspectral images are seems to work here. Okay, so you could take any type of images, be it animals or different objects, anything, any project related to image, you could use this, and this is basically built on TensorFlow. And the second one is audio projects, where you could distinguish between a male and a female voice and lot more. And the third one is like pose project, which is based on the PostNet. So this will capture your body posture and it will tell you what kind of poses you're actually going to give. So we'll try with the image and post project, but then audio, it is not possible because I'm the sole person here, so I cannot be demonstrating with audio project. To start with, we'll go with the image project. Okay, there's two options here. One is a standard model, another one is with use of some microcontrollers. We'll go with the standard image model. So click on the first one, and this is how the outlook is. Okay, so simple. Let me tell you, before you start the project, this is about a classification. Okay, let's take a simple three class classification. So this is class one, second is class two, and if you want, you can add much more classes. This is class three. Okay, going on further, you can add how much ever you want. For now, we'll take it as four class. And you have two options. Either you can upload the images through webcam or through upload option. So I have a very small data set of about 5 images. For now, I'll use that to load it here. So, okay, I have an animal data set of 3 different classes, cat, cow, and dog. Let me take the first one, cat. I'm opening it. So I have 5 different images of cat. Okay, so the 5 images are loaded here. Let me rename it as cat here. Okay, so this is cat. The same way, I just need to load in other set of classes as well. So the second set of class, let me take it as a different type of animal, maybe cow. Okay, so the second one is cow. That is loaded. So I'll just rename it as cow. Okay, and the third class, I'll take one other one, which is dogs. Again, a 5. Okay, so the 5, and this is dog. Okay, 1 second, I'll. Okay, so this is dog. So we have 3 classes, cat, 5 images, cow, 5 images, and dog, 5 images. And for the fourth one, we'll take it as human. And then I'll use webcam to capture my face so that let's distinguish me from animals. So just click on the hold to record option and okay. That's a lot many samples. You see, I just gave it one click and it got 14 samples. Okay, so if you want to delete few, you can use this delete option right there. So I'll just delete few because I don't want to waste time in training here. Fine. So with this, my data set is actually loaded, cat, cow, dog, and a human. So the next step is the training that is over here. So as you could see, if you just click on the train model, that's more than enough. But if you want to fine tune the hyperparameters, like as you could see here, we have different things. So if anyone, if you have an understanding of how neural network works, then you will understand these terms. Like we have epochs, like we are running it for 50 times and a batch size of 16, learning rate is like 0.001. And as I told you in the earlier, like I'm not going to discuss any of these, like what each term is. Okay. But then when you give the number of epochs to be high, it's going to take a bit of time. So for now, I'll give it as 20. Okay. So fine. So that's about the hyperparameters that I want to set. Okay, so you can play around with the different numbers here. And when you increase the epochs, the accuracy is going to be better. So that way, fine. So for now, I'll just give it as 20 and a batch size of 16, learning rate of some 0.001. Fine, just click on the train model. That's more than enough. And as you could see, the model is getting trained. The model training is completed. Okay, so now we just loaded the data set and we trained the model. Now it's time to check the output. So I'm using the webcam to detect if it correctly identifies me as a human. Okay, and as you could see, the human, it's like 100%. So in fact, I'm a human only. So if you want, you can check with other samples as well. Like you click on this webcam and there is an option called file. So you click on the file, you can go and take the samples from your system. Okay, so choose from your file. I have another data set, domestic animals, and there's a cow here. In fact, it's an ox. Okay, so now let's see what it is getting predicted as. Okay, the given image is a cow for about 64%, and it could be a dog for 33%. This is what our prediction is. Okay, so this is what the entire project is. So simple. Just load the data set that you have, train the model. You can fine tune the parameters here and then check the output. Okay, and as I told you, you have just two options, either to upload the images from your system or you can use the webcam. And it's given here, webcam or file. Okay, So this is the first one, Teachable Machine, which works on a image processing based, this one, as I told you, it's based on TensorFlow, basically. Okay, so now you could understand, I think. See, we didn't have a single line of code here, and it's basically like a drag and drop options only. But still, the model was able to predict a decent result despite having only 5 number of images, which is really good, I think. Okay, and of course, as I told you earlier, this is not going to be something worth for a PhD level, but it's worth knowing that we could in fact work without coding. So, okay, let me show you one other project, maybe on this post project. So this time we'll take it a different case. Maybe we'll take it as hand gesture recognition. And again, I'm going to create my own data set here. So the first one, I'll use webcam and okay, I'll use the hand gesture. So maybe I'll use this symbol first, which is a thumbs up. Click on hold to record and some 10 samples are taken. I'll rename the file as, class name as thumbs up. Okay, that's my first class. And let me take the second class as fist bump. Okay, so this is my second class, fist bump. Okay, I'm ensuring that the samples are really so good so that it's very easy to find the final output. Okay, this is fist bump. And we'll take one other class, maybe piece. Something so far. Okay, so this is piece. Fine, just 3 classes I've taken, but then you could see the number of samples actually varies. Maybe let's try with one case where, okay, I'll reduce few samples in the piece. We'll see how the data set imbalance actually affects the model accuracy. Okay, so for one class, I have just taken 6 samples. Another class, I've taken 11 samples. Another class, I've taken 15 samples. So there's a bit of data set imbalance actually. Let's not bother. And as usual, I'm going to reduce the number of epochs alone to avoid training time wasting. Okay, so training the model here. So the model has run for 20 epochs. And now here the accuracy is, okay, my face looks like a fist bump. Okay, it's a piece, thumbs up. Okay, it isn't actually correctly predicting it. Okay, a thumbs up. And then fist bump, piece. Let me try with something else different. High five. Okay, it's actually juggling and it's trying to match to the nearest possible choice. Thumbs up, because for thumbs up, something. Okay, so that's about this hand gesture recognition. So, that's a very simple project again. And as I told you, this model is actually based on PostNet. So the underlying architecture is PostNet. So apart from this, you can use it for other various kinds as well, like driver drowsiness detection, where you give your samples with eyes closed, drowsy, and so much awake and all that and all. Okay, so although this is a very simple project, but let me tell you that there had been very serious case studies with this very simple teachable machine. They have used microcontrollers and so much more IoT devices. I'm not into that area. So they have used that to build a very excellent projects and all to detect something in real. And there had been project which using this teachable machine, they detected snakes actually. So it's up to your creativity. So if you could think of some really interesting image-based or post-based project, then that could really work. Okay, so this is the very simple one. So to begin with, I said this teachable machines. Okay, apart from this, there's one other thing with audio project. Maybe you can try it out at your end, where you have to again give samples with the background noise. Class 1 could be a female voice, class 2 could be a male voice, and you could make a classification saying if it is a male or female. So that's just one thing from my mind. You can think of something else. Okay, so this is about the teachable machine. So we'll move on to the next tool, BigML. Okay, so as the name suggests, this is a very big machine learning platform where you could do a literally lot of things, right from classification, regression, and so much more. And as usual, you don't need any coding knowledge to do this. But then the interface is going to be bit different. I mean, bit complex than the teachable machine that we just saw. because this one it looks a bit technical. Okay, I'll open this with incognito tab so that I'll show you how to start with creating an account. Okay, so this is the website for that, bigml.com. So this one, it's available for both Windows as well as Mac. Mac users can also download this. So bigml.com. So just sign in with your account. A normal Gmail account is more than enough to sign in. So okay, I'll use this. It will just ask you a few questions as to just understand your level of expertise and what kind of person you are in the first place. All that steps are skipped because I've already created an account with this mail ID. And then it will just ask you if you're expertise or if you're a novice and what kind of understanding you have with BigML. Are you a teacher or you a office goer, IT people? That kind of questions will come. Just give it frank answers, and with that, this page should load. Okay, this is your dashboard actually. And in this, you could see the list of data sets that's already available. However, we say them as a sources. Okay, so these are the data sources we have. And the data source could be of different files, like it could be a zip file, it could be a CSV file, and it could be also a text file. Okay, different file formats are actually permitted. And if you want to create your own data set, or if you want to load in the data set that you have in your system, then you have this option, the last option right here, which is for loading the data set. Okay, so as you could see, the first option is you could load from your system. You could load from your local system. Okay, you could load from your local device, or you could use even a URL. Okay, because most of the time we don't have to even download the dataset to our system and then load in. Instead, you can use the Kaggle or GitHub URL links of the dataset, and you could directly load in the dataset. And the third option is to create your own data source. So here is where like you create your own dataset just by giving comma. You can enter the number of lines, and that would create a data source. Okay, so for now, maybe we'll take a simple data source simple data source that's already available. We'll take a simple data source that's already available. So you could see here, we'll take this Titanic survival because everyone needs to understand the data set in order to actually get the problem. Okay, so we'll take this Titanic survival data set. So this is a data source, as I told you. When you click on the data set, it's sending request to see the data set actually. And as you could see, this is what your data set consists of. It has age, the class, the fare, the join date, and the survival rate. I'm sorry, the survived or not. Okay, that's the final target class. And some of the sample instances are actually given. The top 25 are loaded. And this 1, 2, 3 represents, it's a numerical data type. The ABC represents, it's a categorical data type. And the class refers to in which class did the passenger travel, like in the first class or in the second class or in the engine, that way. And what was the fare they gave? It's a numeric value, and joining date, joining is like from where they boarded. So that's again a categorical. And the final is survived or not. So that is again a categorical. So this is what your data set is made of. And if you feel that you want to make some changes to this data set, like since this is from the BigML dataset folder only, this is all perfect. But if in case you are creating a data set, and if it happens to be the case where you by mistake gave a wrong data type, or you want to do some changes, you can very well do it by clicking on this first icon. It's called configure source. You click on that and there are different options to configure. Okay, like you can decide on the separator that you want. If there's any missing values, you can remove it, and lot more. Okay, so this one you can in fact use it when in case you are creating your own data set. If not, if you're using something that's already available, then I think that is not required because the data set is already perfect. Okay, so now the source is ready. We need to create it as a data set. Okay, so what we're going to do is, sorry, click on the Titanic survival. And the second option, sorry, here is where the data set. Okay, sorry, I'll just go back to the first. Titanic survival. The first option is to configure the source. The second option, if you could see, is the configure data set. Okay. Now, when you click on that, there's an option to create data set. This is one way of doing it. If not, you can close that and move on to the next option where you have the first one called one-click data set. Okay. When you just click on that, the data set will get created. Okay. So there's two ways. Either you can go to the configure data set and then click on create data set, or you can move to the next option, third option, and then click on one-click data set. Okay. Both literally means the same. So I'm going to use the third option, one-click data set. Okay. Now my data set will get loaded and then it will show me the histogram. This is the view of a data set. Okay. So you could see that 0 to 5 age, there were like 56 people, and people in the range of age of 55 to 60, there were like 35 people. So that way, this will tell you the entire story of your data set through histograms. Okay. And like there are 9 missing values in terms of age. There are 917 missing values in terms of fair and lot more. Okay. And the total count is as well given here. Now, this is what your data set is. Okay. So the next one is we are going to build it as a model. Okay. Again, go to the same third step. And as you could see here, there's one option called model. So this is the first level, like it's a very simple one decision tree kind of thing. So I'll tell you with that only. So after the data set is created, click on model. Okay. And this will create a decision tree type of modeling, which is like the simplest of all. Okay. So this is your model. Fine. For the whole data set that you have, this is your model. Okay. So when you click on that, so as you could see here, it's going to talk about if a person survived or not. Okay. So let's see maybe the case of this one. I didn't do anything, like I just clicked on that box and it shows that that particular person survived. And this is his data set. Like on the right side, you could see, no, that particular person belonged to first class and the fare he paid was like 4,165. His age was 45 and the fare again he paid was like something like that. Okay, getting back to it, just click on the root node and it will go back. Fine. So that was that for that particular person. And like when you click on that path, it will tell you like the different cases. And finally, it will tell you if a particular person survived or not. Okay, so it will show you the survival rate here and the percentage confidence score. Like this particular person didn't really survive the Titanic mishap, and it's like 61% confident, which means it's not so sure. Like 40% still it is a doubt if the person survived or not. Okay, because we stopped with the very beginning. So when you go down, this confidence score will actually get increased. As you could see, so it keeps on increasing as you go down the node, because when you give more and more factors to strengthen the survival rate, then the confidence score will definitely increase. Okay. So this is a base model based on decision tree. So next what we'll do is we'll evaluate the module. Okay. We'll just see the accuracy and whatever it's possible. Fine, click on the evaluate option. Okay, fine. So the problem here is to evaluate, we need to compare, right? But usually what we do is when we take a data set, we split the data set into 80-20. 80% we take it for training and 20% we take it for testing. I didn't do that, and that's why the evaluation screen is like all empty. Okay, let's go back and do that. Going back to the sources and the Titanic survival. This is the data set we have, and one-click data set. Okay, the data set is getting loaded. It's done. Okay, so here you could see the training test split here. So you click on that and you could increase or decrease that 80%, 20%. I think you could see the slider moving. But like going by the standard terms, we'll keep it as 80% for training and 20% for testing, and then create training test. Now the data set is actually splitted into training and testing. And now the model is getting built only for the training data set, which is 80%. You see that no training 80% is actually given here. Now you can go back and then build a model the same way as we did earlier, create model, and it should build a decision tree type of modeling. Now you know that we didn't train it on the entire data set. Instead, we took only the top, 80% of the data, which means the remaining 20% of the data, we can use it for testing. Okay. Now, when you go and click on the evaluate option, as you could see here, Now it will get evaluated because on this side we have 80% of data. On another side, we have the remaining 20% of data. Okay, now click on the evaluate button and it will tell you. Okay, so this is my final results. The accuracy is not so good, I would say, like it's just around 70%, and the recall rate is 85, the precision is 73, and that's the statistics. Okay, so this is the accuracy of a very simple decision tree. Fine. Now what we'll do is we'll try to change the algorithm and we'll see how the actual thing is going on. Okay, now we'll go to the model again, view model. Sorry, we'll go to the data set because we're going to change the model, right? So we have to go back to the data set source for the 80%. Okay, so you could see, no, again, we are on the same 80% data. Instead of clicking the model, we'll put it as ensemble here. And as everyone would agree, ensemble is like a hybrid model. So instead of trying with a single model, when you do it with hybrid models, the performance and the accuracy is going to be always better. So we'll just test if that really works. Clicking on the ensemble now, and it will tell you like number of models you have to do. Like from number of models is 10 and the type of model you have to take, boosted tree or decision tree, and lot more. Let's go with the standard, default values only. Just click on the create ensemble. Okay, and this would take a bit of time because we are going to create 10 models and then combine their performance and see if it is better than the first model that we created. Okay, so the data set is almost, the model is almost created. Okay, so something it's very bit hard to actually make sense of. Like you could, when you move it, no, like every time it changes and then it tells you the prediction actually. Okay, let's not bother about this. Okay, something is already built. Now just go back and then click on the evaluate button as usual once the model is built. Okay, there's an evaluate option here. Click on that. And now again on the 80% training data and 20% testing data, we are clicking the evaluate button for the ensemble approach. It's telling you your ensemble and data set are being processed. Okay. And the final accuracy, not much better, but still better than the previous one. When we did a basic decision tree, it was around 69. And now when you apply an ensemble approach, it's like 71.49%, which is bit better than the previous one. Okay. The same way you have a lot more. Right now, I just told you one example of supervised technique where you use the models and ensemble. As you could see, there's linear regression, logic regression, deep nets, fusion. There's also algorithms for time series data. There are also algorithms supporting unsupervised data like clusters, anomalies, associations, lot more. Okay, maybe let's try to classify the data. So what we'll do is we'll go to the ensemble again, view ensemble. Okay, and then now last time we clicked on the evaluate. Now I'm going to predict it. Actually, we'll give one sample and then we'll see if a particular person survived that mishap or not. So click on the predict option. So okay, so this is the set of variables we have. Maybe let's change the wage to be 15%, and the class to which the person belonged was like third class, and the fare he paid was somewhere around 8,000, and he joined in Queenstown. Okay, for this kind of data, the person has not survived. Okay, so this is the kind of prediction the model has made. Fine. So there's also one other way to predict. It would actually come in a question by question format. Like here, it came out as this one. No, sorry, like as all variables together, right? But there are also way where you could where it will ask you like question after question, just like a survey. So it will first ask you the age, then this one option. So you could see here, right? Predict question by question. Last time I gave it as predict. Right now I'm going to give it as predict question by question. And it will start asking you the questions here. Click to get the first question. So if a person belonged to first class, only that particular variable. If and all if a person belonged to first class, then the possibility that he survived is really, really low. Like it's only 65% that he survived. He didn't survive. Okay, maybe if you want, you can change the option. You say like we'll give it as the same third class. The next question. Again, it asks for the age. Next question. It asks like where the person border. We'll give that same Queenstown. Okay, so with that and the fare, some amount. Next question. Fine. So for this particular question, like where the class is third class, age is 15, where he boarded is like Queenstown and the fare is like 11,000, the particular person didn't survive. Okay. So you can start over and maybe you can give with other options as well. Fine. So that's about big ML. So maybe I'll just give you a quick recap. I know like this is not as simple as the thinkable machines. So this is the screen. This is the dashboard. So here you have all set of data sources, could be in CSV, zip file, and lot more. So first is that you have to choose your data set. So you have different ways to choose the data set. Load it from your local disk or load it from Drive, load it from Dropbox. There are different ways. Okay, so and even you could load the data set from Amazon, AWS, SQL Server, a lot more. Okay, let's not get into all that. Let's make it simple. So you could load data set from anything. Okay, so the same thing, Titanic survival, just click on the data set. So that should create a data set. Okay, so configure data set, or you could just click on a third option. See, I tell you the third option alone is more than enough to work on this particular tool. Okay, click on the third option and first you have to click on one click data set. The data set gets created. Okay, and once it is created, it's like 95% now. Okay, once it gets created, again click on the third option and then click model. Okay, so because keeping it simple, or you can give any other algorithm that you want. And here you have this random split option as well, which would actually split it as 80-20 only. Okay, so here you can give either clustering, anomaly detection, time series data. Based on the data set that you have, you can choose any appropriate algorithm. We give it as modeling only. Okay, so that should create a model. And then once the model is created, again go to the same third option and then you can click on evaluate. Okay, that should evaluate our model. And again click on the third same option. You could predict anything by using the bulk prediction or question by question format. Okay, so this is a very simple project and there is a lot more. The same decision tree, you can view it as a PDP file like this as we did, or you could even as a sunburst. Okay, like it's like it looks like visually appealing. That's it, but literally it means the same thing. Okay, so but then like we people are like more comfortable with the decision tree, I would say. So we keep it as simple as that. Okay. So we have other algorithms as well, as I told you, for unsupervised, for predictions, and there's a lot more. Fine. So this one, big ML, it's not so new and it's not so old as well. Like the idea started coming out in 2011, and by 2021, this is like a very well established tool. Okay, like I showed you one example with Excel sheet, but now this big ML supports images as well. You could do various kinds of image processing as well. That image processing add-on was released last year only, 2021. Okay, so this is about that. And as I told you, this is for both Mac users as well as Windows users. Apart from this, we have so many other options. I have a list of that. Maybe I'll tell you, but then whoever is interested maybe can take up that. The first one is like create ML. Maybe I'll type it here. Okay, we just discussed this big ML. The next one is create ML. But the problem with create ML is it's only for Mac users. Okay, it doesn't support Windows. So that's one thing with the create ML. And then we have something called as auto ML. I think you would know this. This is from Microsoft. Sorry, this is from Google. One second. Okay, this is from Google auto ML. No issues, but then it requires a credit card to create a free account. The subscriptions are not auto renewed. It's the safe, but then since I don't have a credit card, so I couldn't create one with auto ML. The same problem is with many other tools, but those who have a credit card can start working with this. It's a free tool only. Just for verification, they would ask you the credit card. Then we have something called as Fritz ML. Fritz ML, which supports Android phones, and you could build models on Android phones or even iOS. For that, we have something called as Fritz ML. Then we have one other tool called Google ML Kit. Again, this is for Android users only. So all these are as simple as big ML only. There's not much difference, but then like people are making it for different cases. And one other Mac tool that we have is one other tool is like Make ML. This is again for Mac only. But then this is so interesting. I happened to work sometime long back ago through one of our other faculty system. It works pretty good for object segmentation and detection part. So good using neural networks only. There's not other much simple algorithms only. Using neural networks, this one works very good. But then again, it requires a credit card. Sorry, it's only for Mac users. Okay, that's one thing. Then we have this Auto ML again from Microsoft Azure. And you would know that to have a Azure, you need again a credit card to create an account. So this is Azure Auto ML, which again requires an credit card to create an account. That's one thing. Then there are many other tools like Obvious AI, Runaway AI, and so much more, but everything would be on a demo basis only. So there's like you cannot use it for so long. So that's the problem with these many tools we have. Like if you could generally put it in Google and see that you want to learn the top no code ML tools in 2022, 2021, you will see these names repeatedly coming after. Okay. But the problem, as I told you, is either it is like for Mac or you need a credit card to actually do it. So that's why we couldn't do all that. But then Thinkable Machine, it's all time, anytime free, and it's a very promising website. They are developing so many projects, interesting projects like then and there, now and then. So you could keep a bookmark on that and you could try with different projects. This BigML, it's already well established and like Paka, it has so many techniques, so many algorithms already inbuilt. So you could work with any high-end projects using that BigML. Okay. And there's one other thing called as Orange. I think many people might know this, but still, like for those who don't know, I'll show you a demo of how to work with Orange. And this Orange is like much better than BigML, I would say. Like the interface is so user friendly, so simple to use. But then you need to download the software, keep it in your local device, and then start working on. Okay. So I already downloaded that Orange tool, and I have it in my system. But for those who want to download it, it's so simple like Orange. Okay, so it's basically it started out as an Orange data mining tool, but then now it has come out to be a full-fledged data science tool. It supports all machine learning and deep learning algorithms, techniques, everything. So although it started out as a very small version of data mining only for that basic Excel sheets, but now it's full-fledged. Okay, we have many things you could work on with hyperspectral images, text documents like NLPs, images, bioinformatics, lot more. They have an add-on for every project that you could think of. So this one you can rely again. So this one, so just click on the Orange data mining website, and then there's this called Orange download. Okay, so very simple. Just by clicking next, you could download and install the Orange in no time. Okay, so this one I already have. So let me not download it again. I'll just open the tool that I have. Okay, so this is the tool. So as you see, this is a welcome screen. When you open up, this is the first thing that would come. So you could create a new project or open an existing project. There are video tutorials. Believe me, the video tutorials are so simple. In fact, I started learning from there only. So simple, like they aren't boring as well because the tutorials don't run for more than 4 to 5 minutes. And there are the very super good examples and a documentation, everything. Okay, we'll just close this, and this is our entire workspace. And these are something called as widgets actually. Okay. And if you could know the meaning of each and every widget here, you will master Orange too. Okay. So we have many widgets. You just need to know as for what these widgets are used. If you know that, then you could build very high-end projects using Orange itself. Okay. So file, I think this word would imply the literal meaning. So when you want to load a file, then it's file, CSV file, data table, so much more. This is a first kind, data. The next one is transform, where it has how to merge a data set, concatenate, select it, filter it, aggregate it, and lot many widgets. Okay. Although I'll not be able to cover all the widgets, but I'll tell you the most frequent ones use it. Okay. And the third one is on visualization, where we have widgets for different types of charts and plots like scatter plot, box plot, line plot, bar plot, and lot more. These all are related to visualizing your data set. And then coming to the algorithm part, I mean the model building part, you have write everything starting from decision tree, random forest, k nearest neighbor to neural networks as well. Okay, you could see here, right? We have even neural networks built to this, AdaBoost, Navy Base, and these are the predominant algorithms. Like, of course, everyone would agree that we are not going to require much more algorithms than this. Then we have the options to evaluate. So as usual, when you build a model, it has to be evaluated. We have something called as test and score, which will tell you that accuracy, precision, recall, F-score, and lot much more. And you have this confusion matrix, which will tell you the true positive, true negative, false positive, false negative. You have this ROC curve and lot more. And coming to the unsupervised list of algorithm supported, we have everything right from hierarchical clustering, k-means algorithm, and lot more. Then image analytics. This is an additional add-on. Okay, when you download the Orange, this particular tab will not be available. Since I wanted to show a demo on image analytics, I installed this. Okay, the same way text mining. Again, this wouldn't be available. You have to install it. Okay. So if you want to install any additional libraries like this, just go to the options button here and then click on add-ons. You could see here, no add-ons. When you click on the add-ons, it will tell you the different packages we have. So as you see, image analytics, I installed it. So just click on that and then give OK. It should install the image analytics. The same way text, again, I install. As you could see, there's something called as time series, spectroscopy, network, prototypes, cells, geoscience, and a lot more. Okay, so whoever, like based on your own project, I mean, your research area, you could install the appropriate add-on and start working on. Okay, by default, but only those things are given right from data, transform, visualization, supervised, unsupervised. The rest all add-ons are available for download here, and they keep updating this very often. Okay, one thing to note is once you install an add-on, you have to restart the device to get that add-on right here in the widgets. Okay, unless and until you restart the Orange tool, not the device, you have to restart the Orange tool alone and the widget will come here. Okay, that way I loaded this image analytics and the text mining. Okay, we'll start with a very simple Excel sheet as usual, and then we'll move on to a image-based application, and then we'll finish off with a text-based application. Okay, so like I'll tell you very commonly used widgets and all. The first one is we'll close this because it's unnecessarily occupying the space. But then there are different ways how you could use the widgets here. The first option is to click on the file, drag and drop, put it in the workspace. Okay, that's the first way. If not, I'm just deleting it. If not, there's a very simple handy technique where you could just right click, type it as file, and then the file should come. Okay. So like avoid using this bit because every time you cannot go and search. Like if I want to suddenly if I want test and score, I should go to evaluate, then click on this. Unless and until I know that test and score comes under evaluation, it's a bit tedious. So simple technique is to just right click and then type the thing you want. It should come here. File. Okay. Now this is the file that we have. So here we can load a data set. Okay. So we have already so many data sets that's already available here. When you click on the browser button, you could see these are the data sets that's already inbuilt in Orange. Zoo data set, Titanic, Iris, housing, heart disease, something else. Okay. So you can take anything from this, or if you want, you could go to your own local device and then take the data set that you have. If not, you could even use the URL. Okay. So I'm using a URL this time. What we'll do is we'll go to, 1 second. We'll go and take some your data set. Diabetes, PSV. Okay, let's take it from the GitHub here. There is a data set here on diabetes prediction. So what you have to do is be sure to just go to the raw here because this one is not actually the link for the data set. When you click on the raw, it gets loaded. This is the data set that we are concerned about. Now just copy this link and then you put it in orange there. Okay. Now click on the file and type in the data set that you just copied. Now this is how the URL is. Fine. And as you could see, the data set is already loaded. It is displaying all the features we have here. It has around 768 instances, different columns, sorry, different rows. And we have 9 different features, which are nothing but the columns. And the 9 includes pregnancy, glucose, BP, skin thickness, insulin, BMI, age, and something else. Okay. So this is our data set. Fine. So instead of viewing like this, you could view it as a table because we are comfortable with a table, right? So how you do it is like just drag a line from that and then give the next one. Okay, it comes out, right? Data table. Click on the data table. You can drag it out like any way that you want. Fine. So now this is how the widgets actually communicate. You have a first widget called file, which actually stores the file. And you have something called as data table with which you can view the file in a table format. Now click on the data table and this is what your data set is. Okay. Pregnancy, glucose, blood pressure, thickness, and lot more. Okay. The entire data set is loaded. Fine. Now, in this case, actually the columns are very limited. Like we don't have much, right? Only some 9 to 10. But if in case your data set is going to be really big, and if you don't want all the factors, like there have been cases where there are more than 200 different columns. And you know that all the 200 different columns are not essential really. So in that case, if you want to select only few features, you have an option called select columns. Select column. Okay. Now with this particular file widget, again, I have connected to the file because it should get the entire file from this widget. So we are going to select the column using this. And as you could see, these are the different features that we have. Now assume that I don't want the skin thickness because I feel skin thickness does not relate to diabetes. So what I can do is click on that and then click this icon to remove it. Okay. So now these are the ignored features. Okay. Maybe if I don't want this pregnancy as well, I can ignore it. Right now, my model will be built on these 6 features only. And the target. Okay, so if you know that the outcome is like if a person has diabetes or not. So this is the target variable. Just drag and drop it into the target. Okay, or if you feel that age is the target, then you can drag and drop it here. Okay, then move out it here. Fine, but let's make it meaningful. Outcome is the target of the particular model. And I, in fact, need the skin thickness and pregnancy. So I'm just moving it again here. Now, this is how you can play around with the features. So if in case you're having thousands and thousands of features, you can ignore many features that you feel it is unnecessary because having more number of features is just going to increase the number of time. Okay, the time taken for computation would be definitely increased, be it CPU or GPU. Fine. So that way you can play around with the features. Be sure to just fix the target variable around correctly. Okay. And there's something called as meta. Okay, which gives additional information. Assume that if you have a feature called name, which is nowhere related to a diabetic prediction, then you can move it to meta. Okay, it's just about telling the name of a particular person and then predicting if the particular person has a diabetes or not. Okay, so such additional data, so you can put it in metas. The target variable should be only one, which is the outcome, and the rest all features here. Okay, now I have selected the table here. Now let's view the data table. Since we made some meaningful things, click on the data table and you could see that outcome comes first because that's a predictor variable. The rest all features has went somewhere that side and it's showing something in colorfully. Okay, because we tuned the features. Okay, and one other point is instead of viewing as a data table, you can even view it as a scatter plot because let's play around with the different visualization techniques we have. So there's one thing called a scatter plot. And when you click on the line, it actually says if you want to mark a plot for only the selected data or for the entire data. Click on that line and then give this, click on this, and then give for the entire data, I want to view the scatter plot. So it should be like data to data. Okay. If you want to remove that, just click on that again and then give whatever options you want. Let's make it as data to data because I want a plot for the entire data set. Okay, now click on the scatter plot. So you could see like this is something fine. But as we didn't tune our parameters, this is looking all boring. Let's connect a scatter plot to this here. Okay, and again, let's not make sure that, let's make sure that we are giving a data set for the entire thing. So remove this and connect it with data to data. Okay. Now what this particular line means, I've taken a file, I have processed the columns that I want, viewed it as a data table. Now I'm going to view it as a scatter plot. Okay. Now click on the scatter plot and looks all colorful. Okay, fine. And as you could see, like to the top left, the x-axis represents the BMI, the y-axis represents the diabetes pedigree function. You can even change these functions. Like when you click on the x-axis, it shows you the different options available. Maybe let's give it as glucose. And in the y-axis, let's give it as insulin. This is how the chart looks like. And it's not easy to, like, it's a bit difficult to change this different options every time. So what you can do is click on the find informative projections here. Okay, when you click on this, it's going to tell you the different charts for the entire thing. Okay, just click on the start button. Fine. So now you see in the x-axis, if it is age and glucose, this is how the scatter plot looks like. And if it is BMI glucose, blood pressure glucose, you could see the things changing, right? So this is like the entire projections. Okay. So this is just for like some, when you want to make a paper, then we need some colorful graphs and charts, right? Maybe for that we can use this. Okay, so this is the very basic steps. Okay, like how to view a table, how to view it as a plot, how to select the features, and how to again view it as a plot. Fine. Now what we'll do is, since we took a data set, a real data set, let's try to evaluate the data set. Okay, I'm taking this select and columns and I'm going to use test and score because that is what will tell me the accuracy, precision, recall, and everything. Okay. But then when you click on this, there's nothing because I just gave my entire data set here. There is no algorithm that has been trained so far. Okay. So before we test, we need to train it on a certain algorithm. For now, we'll take it as a simple logistic regression. So click on logistic regression and connect it to the test and score. So when you connect, I think you would have seen that in a fraction of a second, the model got trained. Maybe I'll show you once again. So when you connect on the logistic regression, when you connect, it will get trained. You saw that circle? So that's how it gets trained actually. Okay. Now that our data set source is coming from here and the algorithm is this, we are going to test the model now. Okay. When you click on that, wow, like the accuracy is 82%. Sorry, the area under curve is 82%. Accuracy is 76. Some numbers. Okay. We got something. Fine. So this is for the table. Okay, when you want to mark the table with precision, recall, and all of the factors, you could use that. And for the confusion matrix, because we know that the model is not 100%, there had been few errors. Let's see where the errors are. Of course, you know that we can view it using the confusion matrix. So when you click on that, this is the list of confusion matrix. Okay, so it's all colorful. You see the bottom options. There's something called as select correct, select misclassified. So when I click on the select correct, all this light options, light, what color it is, something light white or something. So those are correctly classified. Okay. Around 1761 instances are correctly classified as no diabetes and 606 are correctly classified as yes diabetic. Okay. Let's see about the misclassified. Click on the misclassified and you could see around 464 of the classes are misclassified here as non-diabetic and 249 as yes diabetic. Okay. So this is where the model has failed. Okay. Now, if you want to pinpoint and see where these values are, what these values are, so simple, just click on the one which you are interested. Okay. Now we have two set of misclassifications. Okay. We'll click on this 464. Okay. Clicking on the 464, we have to view it as a table again. Okay. Maybe data table. Okay. This time I'm going to keep it as selected data only because as you could see here, I have selected one particular box. I'm not seeing it for the entire confusion matrix. I'm just bothered about what these 464 misclassifications are. Okay, so when I do that kind of selection, the line should be like from the selected data to the data. If not, it could be from data to data. But this time, since I'm bothered about only that 464 misclassifications, I'm giving the linkage as selected data to original data. Okay, now you click on this. So these are the 464 instances that were actually misclassified. Okay, you could see the original outcome is 1, but the prediction is actually 0 by logistic regression. This is the original, this is the prediction. One has been like one means yes, the patient is a diabetic, zero means the patient is not diabetic. So around this 464 patients are incorrectly classified as not having diabetic. However, they really had diabetes. Okay, so this is what this is how you will view the results actually. You can even move it this way. So you see now we actually loaded a data set, viewed it as a table, viewed it as a plot. And apart from that, we trained it with a simple logistic regression, viewed the results using test and score for accuracy, precision, recall. And then we wanted to learn as where the model went wrong. So we did it using the confusion matrix. This is where the confusion matrix is. Okay. We have also another set of 249 instances, which are again misclassified. So now taking this 249, and when you click on the data table, this will list out all the 249 classes that's incorrectly classified. Okay. The patient didn't have diabetes, but then it was predicted as having diabetic. These 249 instances. Fine. So this is how you will interrupt a model. Okay. Now assume that you want to test the same data set with one another data set algorithm. Maybe let's take it as random forest this time. So I'm taking another data set called random forest. The same thing, I need to connect it with the test and score. And you saw the model got trained. Now, when you click on the test and score, you could see the results of random forest as well as the results of logistic regression. And you see logistic regression works much better than random forest because the values are higher here. Okay, the classification accuracy is 76%, wherein in random forest, the CA is only 75. Somehow we just need to make a comparison, right? So I did it that way. Okay, then again for the confusion matrix, you can click on that and you can see the results of both the things. Here's the confusion matrix. This is the confusion matrix of logistic regression, and right to the left you have it for the random forest. Okay, so this is how you can juggle and juggle around between the different algorithms you used. And again for the viewing also. Now let's take the confusion matrix of random forest and click on this 313 instances. Click on the data table and it should list you the 313 incorrect instances. Okay, all these 313. You could see the number no 313. These are all the incorrectly classified instances using random forest. Fine. So this is a basic Excel sheet based data set. I mean, an Excel data set. So a pretty simple, like for an Excel data set, I think these options are more than enough to view. You need something to file to load, data table, scatter plot, and this ones. The same algorithm, we could use it for images as well. Okay, we'll see one example with that. Fine. So this is about the orange tool for a basic diabetes prediction system. Okay. So we'll move on to the next one, which is on image-based application. So as I told you earlier, in order to use image-based widgets, you need to install that add-on. I have this image analytics here, but if you don't have, go to the options, click on the add-ons, click on the image analytics, give OK, and then without fail, restart the orange tool. Okay, unless and until you do that, the tool will not load in here. Okay. So last time we saw that for an Excel sheet, we load something called as file, right? So file is for loading an Excel sheet, or it could be a text file, or it could be a CSV file, something like that. But when it comes to images, to load the images, you have something called as import images. Okay. So click on the import images, and when you click, you can load in your data set. Okay. As I was showing you for the previous BigML example, let's take the animal data set that I have. So you see that no, we have 15 images belonging to 3 categories. So this is the information about my data set. Okay. So now the data set is loaded. Now, like for the files, what we did for the files, to view the file, we use the data table, right? So from the data table, you can view the file. The same way for import images, we have an option called image viewer. Okay, let me delete this. So you have the option called image viewer to actually view the images. Fine, when you click on that, you could see these are the samples that I had. 5 in each class, 5 cat, 5 cow, 5 dogs. Okay. Now the same thing, you could even view it as a data table. Let's see what it shows. Again, let's remove the selected images and click it as all images. Okay, from all data to data. And the entire images, we are going to view it in terms of table. Okay. So it made something like it told us the category, which is cat, the image name, C1, C2, C5, the location, the size, the width, the height in terms of pixel, and if the data set had been selected or not. We didn't select any data set, no, so it's coming out as no. The same way we have it for cow, we have it for dog, and for all 15. Okay. So this particular example, we are trying to classify if a given animal is cat or cow or dog. Okay. And with this kind of information, you know that we cannot really classify. How can you even tell if a given image is cat with just the size of an image, width and height of an image? That's pretty useless, right? So what we do is usually we go for the concept of image embedding, which actually creates a vector representation for the given image. As you might know, the entire system works on the basis of numbers, not on images. When you feed an image, the system would read it in terms of numbers only. It cannot understand a picture. It has to transform into a number in order to understand a picture. So the same way we are going to do it. So what we'll do is we'll use image embedding concept. Okay. And the image embedding, we are applying it for the all images as usual. So when you click on the image embedding, you see Orange supports multiple embedders. Inception V3, VGG16, VGG19, these are all neural network embedders. I think you might know. And there are, apart from that, there are many other embedders like DeepLook, OpenFace, Painters. So if and all, if you're working on a face, image-based or a human-based application, then you can go for OpenFace embedder. Okay. Right now, since we are working on images, Inception V3 is the best choice, because the original network was trained on ImageNet, which had animal images. So let's keep it as Inception V3. However, you can check out the results with different other embedders as well. You can even make a small comparison uh, by mentioning the output is so and so if it is Inception V3, the output is so and so if it is like VGG16. Okay, so that's all for the comparative study. Now this is the image embedding. Of course, we'll not understand how it is actually. So let's make it and view it as a data table. Okay, as usual. And then the whole data table is actually taken. So when you click on the data table, now you see, apart from that 6 things that we had, no image name, size, height, width, there are so many other colorful numbers, N918, N919, and it goes till N2047. Okay, which means 2047 different features are actually extracted from the images. Fine. So you could see this top left, no, there is an information like there are 15 instances, 15 different images from which 2048 features were extracted, and it belongs to 3 different classes called cat, cow, dog, and there are 6 meta attributes, which means all useless attributes. No, this 6 image name, all the 6 are now termed as a meta attribute. Okay, because they are no way going to help us in classification. Fine. So maybe if you want to view it more properly, we can give that select columns. And let's put it as for all the data, not for the selected data. Okay, now click on that. As you could see, all the useful 2046 features are now made as a feature set. And the target variable is the category of the animal, cat, cow, dog, and the rest all like the height with the image selected or not, the file location is everything now coming under metas. And let me clarify, the meta attributes will not be taken for feature building or model building. Okay, so these are all ignored. We are just bothered about those in the features. Okay, so now we have this 2046, 47 features now. Fine. So this is how you actually load a data set. So you load a data set and view it. And then when you view images, it's not going to be so useful unless and until you convert into a vector representation, a number representation. So for that, we need this very important concept called image embedding. So in that image embedding, you have different algorithms actually. Okay. So now again, let's test the model, how it's working. So as usual, you go to that option called test and score. You click on that. There is no results here because we didn't train the model with any algorithm yet. Again, we'll take the same logistic regression here this time. So connect the logistic regression with test and score. The model is getting built. And you see the time it's taking. I just had 15 images, but still it's taking a subtle amount of time, right? Okay, something it got trained. Wow, like the accuracy is 100, area under curve is 100, 100, 100, like all pakka. We have got very good results. Fine. So there is no need to actually see the confusion matrix because there is no incorrect data. But still, let's do it for namesake. The confusion matrix says all perfect. All are correctly classified. There are no misclassifications. Okay, that's good. We'll try it out with the same random forest algorithm again. So we have this random forest. We connected with test and score. Model is getting trained. Now let's compare how the result is with a logistic regression and a random forest. Click on that. Again, as you could see for this example as well, random forest is lagging behind logistic regression. The accuracy is only 73% with random forest. So now this confusion matrix, we'll click on the random forest here. This is the confusion matrix of random forest. Select on the misclassified instances and you could see 5 images of dog is actually misclassified as cat. Okay, let's see what are those 5 images of dogs that are misclassified. So I'm selecting this 5 and then to view the images, we have this option called image viewer. Okay, and this time again, I'm keeping it as selected data because I'm bothered about this only 5 images that are misclassified. Okay, let's click on that. 5. Okay, these 5 dogs were actually misclassified as a cat. I don't know why. Of course, I think you would know why it is because we have a very poor data set. Only with 5 images, like no one can actually do the classification. So with such a small data set, of course, we had some problem, but still somehow logistic regression happened to manage to have a good results. Okay, so that's about an image classification. So a quick recap. We started with importing the images. So when you have a bigger data set, you could even try it out with some high-end images, like thermal images, hyperspectral images. I think it should work pretty much well. So load in the data set. You can view the data set using image viewer. And don't forget to use this image embedding, without which the model will not work. Okay, so image embedding, and then you can view the features that you have got. So these are the 2047 features that we have actually got. And then you can train on any algorithms as usual. So this part will be the same for any project. Any project you take, be it a data set, I mean Excel sheet or images, anything you take, this step is going to be the same. However, you can try out with different algorithms. Okay, for simplicity, I'm maintaining it with logistic regression and random forest. Okay, train with the different algorithms, use the test and score to view the results, confusion matrix. And if you want to view where the model failed, then you need to click on the confusion matrix and then click on the misclassification. Maybe let's see this 3 images that were actually misclassified. So these 3 cats actually were misclassified as dogs. Okay, so this is again a kind of misclassification that we had. So that's about I don't know who is that. Okay, I think that's the best word an organizer presenter can hear. Fine, I don't want to hear any such words anymore, so I'll better unmute all the participants. Okay, so that's about the images. Okay, I got to know the opinion from one of the persons, but if there are at least one person who's really listening to this, maybe I'll finish off with one other application which is based on text. Okay, so that I touch upon every one application. No, so the next one is on text applications. Okay, so we'll finish off with this maybe. Okay, so for the text again, as I told you, we need to install that add-on called text. So you go to that options, click on add-ons, and then click on the text here. Okay, so when you click on this text, the text add-on should get installed. Fine. And you could see the text add-on here, and it's on the bottom. You have these add-ons required for working on an NLP project. Okay, so this time. So as you might know, for an Excel sheet, we used a file. For an image, we used import images. Same way, to load a text data, we have something called as corpus. Okay, so this corpus is something which loads a text data. Fine. So click on the corpus, and then there are different different files already available. Let's take about the Grimtails data set because that's what is very easy to understand. So this is a data set. We'll see the data set actually. To view the data set, we have something called as Corpus Viewer. Okay, so this will view the data set. So let's recall, for the file we had data table, for the images we had image viewer, and for the corpus we have Corpus Viewer. When you click on that, you could see these are the different stories that's available under Grimpar. Okay, like we have around 44 different stories, and these 44 stories are actually classified into two categories. One is Tales of Magic, which talks about the king, queen, and how people are. And there's one thing called as animal tales, okay, which usually describes different animals. Fine. So this particular data set, we have 44 different stories, which is classified into an animal data set and a Tales of Magic data set. Okay. So we are going to try to make some classification or clustering, something. Okay, maybe whatever is simple. Fine. So when you click on the corpus viewer, it says this is the topic it which it belongs to. It is animal tale. This is the title, Pack of Scoundrels. The abstract is given. The content of the story is given here and the type. Okay. So this is how you have to view. Like there is a Little Red Riding Hood, which everyone knows. Title is Little Red Riding Hood. Abstract is given. Content of the story is given. Fine. So this is our data set. Now, let's view this data set as a bag of words because that's a bit interesting, no? So we'll view it as that. So, sorry, we'll view it as a word cloud. Okay, so Corpus Viewer is one way to view the data set. One other one interesting way is word cloud. So it tells you like the more and more number of times a particular word is used, it will be in bigger font. Okay, so the word the is bigger of all because that had been used for so many times. So that's in the biggest of all size. Okay, so that's a word cloud. But when you click on the word cloud, you could see that it's not so informative because it's showing all the punctuation marks and a lot more unnecessary things. Okay, we know that if it is a text, it will have definitely lot many full stops. See, the full stop is being in a bigger size. So you can remove all that by pre-processing your text. Okay, so you have an option to pre-process the text. The same thing as we study, like you can remove the stop words, you can work on the punctuation marks. So this is how it is. So it's going to convert all the text to lowercase. It's going to remove the white spaces and it's going to neglect all these types of punctuation marks. Okay, so this is how the pre-process is. Now, after pre-processing, let's again check the word cloud. And now you see we don't have all that unnecessary punctuation marks and all. It's all gone. But still, as you could see, there are many useless words here like go, said, saw, done. These are all useless words, right? I would say these as a stop words. So what we can do is you can create your own notepad and then start typing all the unnecessary stop words like go, what else could oh, okay. Whatever word you want to remove, no, you can save it. You can type out like the entire list you can type out, store it there. I'll give the name as stop words, SW. And now when you click on the pre-processing again, there is a folder here, stop words. There is a folder here, no, just click on that and select the words that you have typed, stop words. Okay, now after pre-processing, now click on the word cloud. Now all those unnecessary words will go. Fine. I didn't do any meaningful words, so it's still there. But then you can see if you want to remove this go, actually you can go and edit that Word document and then see if it has went or not. Okay, so this is a way to view your entire text. Fine. So then one other thing important about it is like, although you know that, okay, of all Kame is bigger because that had been used many number of times, but you don't know how many times it had been used. So what you can do is you can click on bag of words. Okay, so as you know, bag of words will give you a count of how many times each word had been represented. Okay, so to view the bag of words, so you're going to give it as data table because the output has to be displayed as a table and then you can view the number of times each word has been done. Okay, so you could see that the word able was repeated one time, afterwards one time, and the word alone was given two times. The same way, it will give you the entire set for the first tale alone. Okay, the same way you can view it for the entire data table. Fine. So this is the basic widgets required for a text. Like you load a data set with Corpus, you can view it using Corpus Viewer, like which will tell you the entire story of your data set. Or if you wanted to view it as a book cloud, you can view it. And if you want to remove all these punctuation marks and unnecessary words, you can use pre-processing text where you can give your stop words list again and then view it as a word cloud, which would look much better. And then if you want to know the counts that you have in your text, then you can give. Okay, there's different options, binary, sublinear, count and all. So you can click on that and then give data table, okay, which will tell you the number of times each word had been repeated. Okay, maybe let's try with clustering alone. So in order to do the clustering, I think you would know that it needs to calculate the distance between each of the words. Only then it can cluster, right? So by calculating the cluster, we have different clustering options again. Sorry, distance options. Like let's take it as cosine because that would be more appropriate. So after doing the distance, after measuring the distance, let's cluster it using hierarchical clustering. Okay. So this is the hierarchical clustering we have, right? As you could see, uh, okay, so you see that no, the number of clusters C1 to C34, as and when you drag the line, you could see the number of clusters getting reduced. Okay, so all this blue belongs to cluster 1, red to cluster 2, cluster 3, 4, 5. And as you know, this whole 44 stories belongs to just two clusters. One is Tale of Magic, another one is Animal Tales. So let's fix it as this one. Okay, these are the two different clusters we have. So as you could see, all the red colors belongs to Animal Tales and all the blue colors belongs to Tales of Magic. However, there are few misclassifications. See here, Animal Tales has come to table of Tales of Magic. There is another one. So if you want to see why that had come out as a mistake, you can just click on that. Maybe this one particularly. Okay, so maybe let's see why this particular, why this is coming out like this. If you want to understand that, then you can give it as Corpus Viewer. Whenever you want to view a selected thing, you can use the viewers there. So Corpus Viewer. Okay, so as you could see this, fine. So since the word wolf was coming, it has misclassified as a animal tail. Sorry, this tail. Okay, you could see that, no? This particular title has both wolf and a kid. So the clustering technique got confused if it is an animal tail or a tale of magic. The same goes for the Snow White. Okay, so that's why it's actually misclassified. Fine. So I think I'll stop with this. A quick recap of the text. So we have this corpus to load the data set. And then we have the corpus viewer to view your data set, word cloud to pre-process it. We have this pre-process widget. And then you can even do the clustering. There are other classification techniques as well, but I know how you're all feeling. So I'll stop with this only. Okay, so with that, I'm stopping. So we just started out with how things work with Thinkable Machine, where we did this image project and a few pose estimation, followed by BigML, which you could use it for anything. And then we did this orange tool. Okay, so as one other speaker was saying, we have one other interesting tool called Nime. But then like the interface is going to be a bit different from Orange. For me personally, Orange is much more flexible as it's very easy drag and drop only, but Nime is totally different. But coming to the effectiveness, Nime is much better than Orange. Okay, fine. So with that, I'll stop. Any quick queries you can ask me.